Welcome back to section 6.5. This video will cover examples 5, 6, 7 in your notes. You'll learn how to multiply and divide complex numbers written in trig form. So in this section, you will be given a formula you can use, but it's very important that we spend a little bit of time right now and actually see where it's derived from before we apply it. So this trig form adapts nicely to multiplication and division of complex numbers. So say you're given two complex numbers, z sub 1 and z sub 2, and asked to multiply them together. So I'm going to multiply all of this times all of this. Just to keep my work nice and neat, I'm going to put r sub 1 and r sub 2 in the front. Then I've got cosine theta 1 plus I sine theta 1 times the quantity of cosine theta 2 plus I sine theta 2. So I'm going to distribute this cosine across both and come up with cosine of theta sub 1 times cosine theta sub 2 plus, I'm going to keep the I in front, so I'm going to have I cosine theta sub 1 times sine theta sub 2. Second distribution, I have I sine theta sub 1 times cosine theta sub 2 plus I squared sine theta sub 1 times sine theta sub 2. And of course, r sub 1 and r sub 2 are still in front. All right, so I need to clean this up. Now looking at each term, I see they're either all real or all imaginary. Looking at this last term, I see that I squared is really the same thing as negative 1. So if I simplify this portion here, this last term is really minus sine theta sub 1 times sine theta sub 2. So I'm going to pull all of my real pieces together and all of my imaginary pieces together. So my real include the first term, because there's no I, and this last term. All of my imaginary pieces would include, let's see, I cosine theta sub 1, sine theta sub 2, I sine theta sub 1, and cosine theta sub 2. So let's group those together. So R1, R2 are still hanging out. So the real pieces, we've got cosine theta sub 1, cosine theta sub 2, minus sine theta sub 1, sine theta sub 2. All right, now the imaginary pieces. So I'm going to pull out an I from this first blue term, cosine theta sub 1, sine theta sub 2, plus sine theta sub 1, cosine theta sub 2. Close brackets. All right, so I've got a real and an imaginary part. Now looking at this real piece, it brings a double angle formula to mind. So let's pull up our double angle formulas. All right, so in the real piece, in the yellow, I see I've got cosine of u plus v. So my u, of course, is theta sub 1, and my v is theta sub 2. So if I condense it, I really have cosine of theta 1 plus theta sub 2. And of course my r sub 1 and r sub 2 are out front. Now looking at my imaginary piece, blue, I've got cosine, sine, sine, cosine. So they're in a little bit of a jumbled order, but it looks a whole lot like sine of u plus v. So u would be theta sub 1 and v would be theta sub 2. So my imaginary piece can be condensed into I of sine theta sub 1 plus theta sub 2, and close brackets. So when we're asked to multiply two complex numbers that are already in trig form, we simply multiply their r's together. Inside the parentheses, we take the sum of theta 1 plus theta 2. That'll be our real piece. So cosine of the real. And then sine, again, we take the sum, will be our imaginary piece. So we have this a little bit more formalized here. We see that if we multiply, we simply multiply the modulus, so the r values, and take the sum of the arguments, so the thetas. All right, so let's try an example here together. So find the product of the complex numbers. I notice they're already in trig form. So z sub 1 times z sub 2 is equal to, well, my formula is r sub 1 times r sub 2, bracket, cosine of theta sub 1 plus theta sub 2, plus I sine of theta sub 1 plus theta sub 2, close brackets. So my r values are 3 and 2 is 6, open bracket, cosine. We add the arguments, so 1 pi over 4 plus 3 pi over 4 is pi, plus I sine, and add those arguments, which of course is the same number, close brackets. Now we can simplify this a little bit, because we know the cosine of pi is -1, plus, don't drop your I, the sine of pi is 0. So here, this actually cancels off. So the only thing I have left is -6, which we give as our final answer. All right, go ahead and try exercise 65 in your notes now. Make sure that if you can simplify like we did in the last problem, simplify as completely as possible. Check your answer in the back of the book. Come back when you're done. All right, in example 6, we're asked to find the product of z sub 1 and z sub 2. Good mathematicians start writing down the formula they want to use. We've got r sub 1 times r sub 2, bracket, cosine theta sub 1 plus theta sub 2, plus I sine theta sub 1 plus theta sub 2. So our r values, of course, are 2 and 8. So their product is 16. Let's see, we've got cosine, let's see, 2 pi over 3 plus 11 pi over 6. If we get a common denominator by multiplying the first fraction by 2, we get in the numerator 4 pi plus 11 pi is 15 pi all over 6. You can reduce that down by dividing top and bottom by a factor of 3. Divide by 3, get 5. Divide by 3, get 2. So now we're at 5 pi over 2. But remember, we're working on the interval from 0 to 2 pi. And 5 pi over 2 is too large. So if we subtract off 2 pi, or 4 pi over 2, we get pi over 2. So I'm going to use pi over 2 here, plus I sine pi over 2. Remember, our arguments, our theta value will be the same for both. So we've got 16. Let's clean up the inside. Cosine of pi over 2, think on the unit circle. What's your x value when theta is pi over 2? Comes out to 0. Plus I, don't drop your I. Sine of pi over 2 is 1. So this 0 is gone. So we just have 16 times I, or 16I. All right, go ahead and try exercise 67 in your notes now. Do be sure to simplify as much as possible. Check your answer in the back of the book. Come back when you're done. When we're asked to divide two complex numbers written in trig form, a very similar pattern emerges. So we've got z sub 1 over z sub 2. Instead of multiplying the moduli, we divide. Instead of adding the arguments, we subtract theta sub 1 minus theta sub 2. They also tell us it's important to note that z sub 2 can never equal 0 because that would lead to division by 0. So let's try an example together. So find the quotient of z sub 1 and z sub 2. All All right, so good mathematicians, start by writing down the formula. We've got r sub 1 over r sub 2, big open brackets, cosine of theta sub 1 minus theta sub 2, plus I sine theta sub 1 minus theta sub 2, close brackets. So, of course, my r values are 24 and 8, so divide those through and get 3. We've got cosine of 300 minus 75 equals 225, plus I sine of 225. Now think unit circle. Here's 180 degrees, here's 225. So on the unit circle, we've got negative root 2 on 2, comma, negative root 2 on 2. So when we simplify inside, got 3. Your cosine is your x value, so negative root 2 on 2, plus I, and your sine is negative root 2 on 2. So I'm going to change this addition to a subtraction. And the only thing that we have left to do is to distribute this 3, or 3 over 1, to both of these terms. So we've got negative 3 root 2 over 2 minus 3 root 2 over 2, and the I goes in back. That's your answer. All right, go ahead and try exercise 73 in your notes. I see that z sub 1 is here, z sub 2. Make sure you actually write down the formula. Check your answer in the back of the book. Come back when you're done. All right, go ahead and try the wrap up for day 2 in your notes now. First, just find the product. I see your r value in both cases is 1. In number 2, find the product. Here your r value is 3 and 4. And number 3, find the quotient. Come to class with questions. I'll see you soon.